Hey guys, so first of all, update on the cats. They've been taken to the vet. They're fine. They're gaining weight as they should. This is little Ravioli and this is Pesto, and they're really cute and really inquisitive, and you're gonna see a lot more of them hopefully. And yeah, they're the cutest little cats you've ever seen, and they're always trying to steal stuff, and they're very playful, and they sleep in a drawer, like in a nightstand drawer. They're great. So everybody say hi to the cats. They're the official lab cats for Gears and Gear. And yeah, so it's Sunday. I've obviously been painting, and I did go to the flea market yesterday, and I got a load of things that I was going to show to you. But the thing is that none of it's as interesting as one of the items that I found, which completely steals the show. And it's really big, it's really interesting, and just my having it might consist of quite a bit of a legal conundrum for the Romanian state. I don't know how these make it up into the used market. So without further ado, here we go. This is a Romanian made night vision scope for armored vehicles, for heavy armored vehicles basically. It's also a periscope, so you can see the viewfinder is here, and the objective lens, actually the prism for the objective lens, is about 200 millimeters taller. And there's some Romanian writing saying that the apparatus or the device shall be kept for storage with the prism and the eyepiece covered. That's the first two lines, and the position of the shutter in the closed position basically. It is forbidden to turn on the device during daytime or in bright light. And the next lines are very fun. It says, if during the operation of the device and the field of vision of the thing there's any flashing lights like car headlights or explosions, it's recommended to cover up the basically the image intensifier portion of this thing with this slider right here that I'm moving. The device has a 26 volt plug. I'm going to show it to you a bit later. It's got an on-off switch, a fuse down here. And what is this thing? Because I haven't mentioned yet. So this is a night vision optics basically. It's a high voltage generator with an image intensifier tube here, and a basically a set of optics that take an image from on the battlefield and project it on the image intensifier tube, and then spin it around a couple of times in order for the operator to be able to see. I did test it. It does work, but with a major caveat, which is that the intensifier tube is so weak that it barely works for daytime. So in daytime it would be extremely bright. Have to be extremely bright. That's why you're not supposed to turn these on during daylight. But it can barely cast a picture when it's reasonably lit outside. So I'm going to insert some images from that, and in the meantime I'm going to tell you about an interesting thing. So the Romanian Optics Institute, IOR, IORE, which is based here in Bucharest, still makes a successor model of this thing. This is named the AON-4. The other one is the same AON, but with a different number after it. So AON means Aparat Ochii Repetind de Noapte, which means night vision spotting device. This is the plug I was telling you about, the 26 volt power goes in. They still make one of these things. It looks exactly the same with a bit of an updated power supply, high voltage converter, and I think a newer generation image intensifier. Funny thing is that at one of my previous jobs, I worked with somebody, a very nice guy, who worked for the Romanian Optics Institute as an optician, optical engineer, and fine mechanical engineer. So he didn't work on this particular model. I actually called him and told him about this thing. He stopped working at the Romanian Optics Institute when they switched to the second generation of image intensifiers. So he did design image intensifier gear, just he didn't work on this thing particularly. So basically a quick theory of operation, how these things work is there's a bit of optics here. First of all, there's a prism which rotates the beam, actually the image, it flips it 90 degrees this way. So the image would go in here, get spun around 90 degrees and go into a sort of collimator lens or an objective lens, which focuses the image to another prism, which I assume is in here, and then it projects it into the input side of the image intensifier. The image intensifier is powered up by, I don't know, several tens of thousand volts, and it intensifies the incoming light, mostly in the infrared region, and it shoots it up on a green phosphor screen behind here. So this thing, as it still is, if I were to get a new image intensifier and just swap out that component, the thing will still work. It's perfectly fine. It's actually in extremely good condition. I don't think it ever saw any form of like operation theater or something like that. I think this was a training model. But it's not working as it should anymore. So its nighttime sensitivity is terrible, and the tube doesn't have that many blemishes on it, so the image isn't spotty at all, but it's not doing a very good job of intensifying the image anymore. I don't think it's the high voltage converter to blame, so that thing should still be operating properly. At least by the looks and sounds of it, but the device itself, the image intensifier itself, is either worn or has been exposed to light or something else, or is just extremely old and has failed in time. This was made in 1987, so it's about, I don't know, let's put it this way, it's almost 20 years older than me, 18 years older than me, something like that. No, sorry, 8 years older than me, Jesus. Okay, anyway, because this thing is as dead as it is, I'm not gonna feel too bad about trying to take it apart, not very carefully. I'm still gonna try and make it go back together as nicely as possible, because it's just a very interesting display piece. It's quite heavy. It weighs in at around, I don't know, 6 kilos or something like that. It's supposed to be a... You're supposed to have like a 200-meter useful range of vision. There's a small collimator point in the viewfinder, and I think it's... when a thing about the size of a human being is filling up that crosshairs, you can range it at about 200 meters, and you can adjust for eyesight. So there's plus minus 4.5 diopter adjustment. There's a headrest here. And yeah, this thing was made to be mounted on a piece of equipment, like an armored personnel carrier or something like that. So you wouldn't be lugging it around like this. It needs an external power supply, first of all, and it's very heavy. So Oh, and one more thing. This is the official, I think, the official color of the Romanian army equipment. So it's a kind of hammerite green. And there was a mechanical factory in a city in Romania called Cugir. And they used to make sewing machines under the brand name Ilana. I might insert a picture of one that's from my grandparents' house. Those sewing machines were made in the same city as Romanian armaments. And there was a funny joke back in the day in Romania, two housewives asking each other, so Maricica, did your husband put together that Ilana sewing machine that he got for you? Yeah, sweetie, he tried putting it together like 5 or 6 times, but it still assembles like a Kalashnikov. So yeah, and the same color was actually used on most Romanian machine tools. So sewing machines, military equipment, machine tools. And Romania used to make quite, I would call them decent quality machine tools. We had the universal milling machines, we had decent quality lathes, we had a series of lathes named Iosif Vrenget, which were clones of the Monarch American lathes. And then we switched to our own design with the SA and this SN series of lathes, which were also exported under the brand name. It was something related to mountains, I'm not entirely sure. But so Romanian lathes made it quite a fair bit around the world. I've seen one for sale in New Zealand, if you can imagine that. And they were very, very robust. Like the ways on the machine and the bed were incredibly thick, very thick cast iron, induction hardened. They took the technology from Hardinge and Monarch and the guys like that. So they didn't rip off the Soviet machines, which were rip-offs of Westerners' machines as well. But they did rip off the Americans straight off. So if you look at a Iosif Vrenget style lathe, you're going to see a very clear similarity to a Monarch 16CY or something like that. Including the head castings are the same, the change gears look the same, the change wheels look the same, and the bed has the same general, the lathe has the same general aspect to it. So I'm not sure if they were one-to-one copies, but yeah. And the Romanian milling machines were usually ripped off of like the Euro-style mill, like the Schaublin 13 and stuff like that. But they were usually much more overbuilt, ridiculously overbuilt, to the degree that the Schaublin weighs around 500 kilos, a 13, and the Romanian equivalent weighs around 950 or something like that. There is a famous drill press, Romanian gearhead drill press. I had one of those. I'm going to insert a picture if I can find it. The electrical panel is made out of cast iron. And the back side of the cast iron, like the door that hinges open, is like at least 5 millimeters thick. So they had a load of iron that they could cast into various things, and they made everything as robust and as rugged as they could. The reason why none of the lathes you can get in Romania secondhand, especially Romanian-made ones, are any good still, is that they were very poorly maintained. So they should have had a capital restoration every year, or 16 months or something like that. So every 12 to 16 months, the lathe would have been torn down, bearings reset, plays reset, wear investigated in the bed and the ways, and alongside the usual maintenance of oiling everything and changing out the oil and cleaning out the pumps and stuff like that. Once a year, or almost twice every 3 years, you'd have to take the lathe completely apart and put it back together, changing whatever you needed to change. That never happened. What they did was, and this is true because I've seen it, every year they would slather on a brand new coat of paint. Because one of the milling machines that I had at least 24 different colors of paint chipping right off. So you could like peel layers of paint off of the machine and go back in the past and see how many times that machine was repainted instead of being restored. So never buy used Romanian milling machines or lathes. If you do, make sure they're not worn, because if they are, you're kind of screwed. The 500 series of lathes, so 500 millimeter swing over the bed, had extremely nice gamma bearings in the headstock, and they're like, if you were to buy a brand new set, it would be like 2,000 euros. So if you get a lathe with bad bearings, you're screwed. Yeah. Okay, I'm going to take this thing apart carefully, and I think we're going to start at the optics and move our way down and see what we can reveal about the inner workings of this thing. So, spoiler alert, I've already been inside here a bit. As you can see, this thing wasn't screwed back together, and it's probably going to be a bit of a bear, because all the screws are pan heads, and some of them look like they're not in great condition. You can see the phone recording there. But yeah, I hope this is going to be interesting and worth it. And a bit of history about Romania, things people don't usually tell you about in history books. Everybody knows about Ceausescu and the subway disaster he did in Bucharest and other stuff like that, but you don't know how deep the rabbit hole actually went. Like when they were closing down factories and stuff like that, to get raw material like cast iron and stuff like that, they would just pick up the milling machine or a bed or a lathe with a crane, remove the brake from the crane and let it smash into the ground. The lathe would crack in 1,000 pieces, and they would just throw it into the smelter and make brand new cast iron. So yeah, that's how Romania's industry was destroyed. Okay, I'm going to get the cats out because they're gnawing at my feet right now, and I'm going to start taking this apart, and we're going to discuss about a bit of the things that we find inside. Okay? Catch you soon. Oh, by the way, I don't know if you know that crazy Canadian guy, Hand Tool Rescue. I hope he's Canadian. He made a copy of this. This is a King Dick adjustable spanner or wrench or whatever it is. And this thing is over 100 years old, I think. And I found it at the flea market. There is a guy who has a very old tool sort of shop there. And I don't know where the hell he finds them. He restores them beautifully. You can see that this one has been restored just enough to keep its original patina. It's beautiful, and I just love it. Like, King Dick is still around after all these years, and this is a fantastic tool. Heirloom quality. It's worthless these days. Like, come on, who's gonna use this as an actual spanner to work? It's gonna round nuts left and right. But as a piece of history, and for 20 bucks, this was excellent. Like, absolutely, truly excellent. Okay, let me get back to taking apart the night vision thing, and I'll be right back. Alright, so the first thing you're going to see is this beautiful prism. It's not a mirror, it's a prism, and I think you know that prisms are kind of hard to make. They're very expensive, and this is very good quality glass. It's got excellent surface finishes everywhere. And there you can see the collection of Keithleys and the Prema from Mr. Reps. Anyway, this is the first thing that popped off. It's just a prism. It's reasonably heavy. And the next thing we're going to take a look at is down the hatch. So we can see a very large piece of optics in there, which is basically it's a telephoto lens. Nice O-ring to seal everything, and goop. This is some sort of wax, or I have no idea, some sort of grease which was meant to seal the to make a better seal, because a plain O-ring will never be fully waterproof. You need some grease in there to fill up the microscopic crevices. And also, this thing originally would have been purged with something like nitrogen or an inert gas with very low humidity, so it would not fog up in cases of extreme temperatures, right? So I'm gonna dig in a bit further. I'm gonna bring you back when I have some more things revealed. So one of the things that just occurred to me right now was, if this thing was meant to be mounted on a piece of equipment, why would you need the handles? Where the handles are for you to hold on to the thing, not for the thing to hold on to you. So in case the thing is moving around, you know, hard terrain, rough terrain, you'd be supposed to hold on for dear life with these things while looking through that peephole and trying to find the enemy. Which is, in Romanian, the word for the enemy is inamicul. I don't know where that word comes from. Surprisingly, I don't think it's from French, because it doesn't sound a lot like enemy or whatever the French word might be for that. Okay, let me cut the monkey business and I'll keep tearing this thing apart. Alright, so I had to bring out the extendo flathead. You can see that the last piece I removed was just a sort of hood. Actually, it's an extension, it's an optical component as well, because it makes sure that the prism we saw earlier was at the correct distance away from this lens in order to, you know, have the thing do what it's supposed to do. And another tangent, because that's what this channel is all about now. If you're into electronics or mechanics or anything, and you don't have a pair of these, what are you doing with your life, man? Like, this is I think they're called forceps. In Romanian, it's a pinça. Like a pincer, basically. It's the same kind of word. It's pinching, so this will latch together and be very tight. It's meant to hold wounds open and in surgery, or clamp blood vessels shut or something, in aiding like suturing a wound. And I have a straight one and a bent one, and they're just amazing for reaching into tight places and getting a good grip on small things. And you don't have to worry about gripping small things and holding things, holding this closed, because it will close and stay latched for you to just, you know, do whatever you have to do. So I use this to plug in the front panel connectors in my PC. It's the best way to do it. Okay, I've managed to detach, the high voltage module generator from the rest of the optics, and we can take a look at both of these things separately as soon as I figure out how to take the image intensifier portion out. So give me just a second. Alright, that was a nightmare. Okay, so I don't know why, but they insisted on using flatheads everywhere, and I was very terrified from prior knowledge that these might, you know, just either snap or strip out completely. So I brought in the big guns, managed to extricate them extra carefully, and you can see the image intensifier is this component right here. I have no idea what kind of generation this thing is, but that's the photocathode, and this is the phosphor screen. So basically, and you can see, I hope, there's the crosshair I was talking about. I was worried it might be a scratch at first, but I then remembered that no, it's supposed to have that. So light hits this thing, it generates photoelectrons, and under the enormous DC bias, they're accelerated towards the phosphor, and I'm assuming that the internal geometry creates a gradient, like a field gradient inside, that acts as basically an electrostatic mirror, which focuses the amplified, the greater number of photons, electrons basically, sorry, to hit the phosphorus in order to get light amplification. This is my understanding of how these things work. So basically it's just a there might also be some secondary emission somewhere around in there in order for you to get like 3 electrons off of 1 photoelectron that's generated from the get-go, but I'm not entirely sure. This thing is gunky as hell, so this is some sort of O-ring, silicon O-ring or something like that to seal the front of the tube. And there's the shield. This is to shield the basically the tube in order for it not to develop like corona, because these things run at pretty high voltages. And you can see the anode cap in there. I think it's the anode cap, since this is a photocathode. Yeah, it should be an anode. Right, so let me figure out how to irreversibly destroy this thing and take it apart so we can see everything about it, and I'll be right back. I've never sworn so much in my entire life. Couldn't let you hear that, guys. Holy crap. You didn't hear that. So this is the image intensifier. Wait a second. I'll be right back. Well, I can't find the other one that I had. The one in the previous flea market find videos, but it's basically the same thing. So as I said, there's a very particular geometry here, and you can see the coating on this thing is actually kind of peeling off, and yeah. So inside, if I were to take off the entirety of this doping, corona doping, or whatever you call it, you'd see that there's the photocathode right there with that crosshair I was telling you about. This is the anode connection, the spigot, and yeah, that's the phosphorus. That's basically it when it comes to what this thing is. And all the things you've seen so far are to just get an image onto here and to get high voltage in here. That was not worth the effort. God damn it. Look at the extents I go to for you guys. I mean, it's very interesting, but that was a bear. Alright, there's one more. Jesus Christ. Dirt. There's one more thing, and I might just take it apart with you here. So I had to actually snip the high voltage lead to the thing, so it's never gonna go back the same way it was. Are you upset? I'm not upset. It's for learning. I'm gonna learn you a thing or two today. So yeah, as I don't know if I told you about this thing, but Romanian anti-theft tags or anti-tamper tags were very interesting. So this one, as I said, I've already taken apart, but previously, around some of the screws, you can usually find small cups. So the screw head fits inside a cup, and it's poured over in some sort of brittle wax. And that is a means to prevent anybody from tampering with the device, because in order to get your screwdriver into the screw to take it apart, to take the thing apart, you're going to need to tamper with the tamper seal. And this goes back to when people would steal basically the precious metals in the capacitors and electronics and stuff like that, because not only will the thing not work anymore, but there's also theft against the communist regime, the party. So what we got here is a giant block of snot. So this is a very interesting, it's a jelly basically. It's high voltage inhibiting. And one of the comments I was going to make was, there's this hole here, right, which is tapped for a screw, and the screw was fixing the braiding. Well, when they screwed it in, they nicked the gel itself, and there were a lot of filings, like the aluminium shredding under the influence of the screw. Okay, let me just take this thing a bit further apart and we're gonna discuss about what's going on inside here. Okay, be right back. Jesus Christ, military gear, am I right? So, backstory again. These are Romanian made 2 and 30 55s. And they were made right here in Bucharest at the former IPRS factory. And inside here, we can see some, well, first of all, a transformer, right? You can see a transformer. It's sort of like a flyback. I am actually pretty sure this is just a flyback transformer repurposed from some TV or something like that. And then we have 3 and another 3 diodes. I'm pretty sure those are diodes because they can't be anything else conceivably. I don't think they're resistors. And we have 2 doorknob capacitors. So the orange things. So these are diodes and capacitors because they run on, these things run on DC. So, and the feed through for the outside is way down inside that hole. So basically, this is just a high voltage generator. From the looks of it, I would expect it to be in the neighborhood of 50,000 volts. So you can imagine there's quite a lot of electric field inside of these things. Alright, so I might give it a shot. Just slicing this thing open and seeing if I can expose the goodies inside. It's very, very dense, just like myself. And it's now completely ruined. Thanks a lot, you guys. Okay, I'm gonna take this thing apart and even further, I'm gonna break it down to individual atoms, I think. I'm gonna take this thing, slice it up with a scalpel, and by the way, if you don't know what kind of scalpels to buy, I recommend Swan Morton scalpels. They're the best. Hey. I've seen them. LCC made in France. Of course, Romanians didn't have the technology to make high voltage capacitors back in the 80s. Or good quality high voltage capacitors. So, yeah. Hey. France made capacitors? I have no clue. 470 picofarad, 20 kilovolts. So, might be 40 kilovolts or less. 35 if they're in series. Yeah. I'll keep at it and I'll bring it back. Alright, so enough jelly to make a water cake. These are, it's getting funnier and funnier by the second. These are Soviet diodes. This is a French capacitor. And I don't know what you know about the French and the Russians, but I don't think they were ever very good friends. And this is, it just strikes me as very funny. So these are 5 kilovolt diodes, and they had 3 in series, and I think it was just basically a 2-stage Cockcroft-Walton multiplier or something like that, or it's not even 2-stage, because anyway, a Cockcroft-Walton multiplier or something like that. Yeah, very, just the collaboration between two nations that I don't think they ever knew what their products were being put into. Maybe the Russians, but gee, the French, they definitely didn't know that their products were going into military equipment. Like, these are just basic film capacitors for high voltage. They look very cute. Oh, by the way, you can see the draft angle from when they were potted. They were pushed out this way. And underneath here, I don't think there's anything. There might be a resistor or something, but yeah. So 15 kilovolts worth of diodes. And a day's worth of trash. Oh, cleaning this up is going to be a mess. Nightmare again. The transformer is just a basic, like, I've seen this style of core in black and white TV sets from basically Romanian made. And yeah, if I just carefully extract this capacitor as well, without knackering everything around, I think I'll have 2 French capacitors and 6 Russian diodes, and I can make a multicultural Cockcroft-Walton multiplier. That's a mouthful to say. Oh, interesting way how they connected the high voltage. So this was the output of the thing. So I don't think it even was a Cockcroft-Walton, just straight diode capacitor rectified, and that's it. So yeah, maybe 20 kilovolts, 15 kilovolts, something like that for this tube here. Anyway, guys, I'm going to spend the next hour and a half cleaning the mess I made up, and that's kind of it for today. Hope this has been interesting and educational to a reasonable extent. And if you have any questions or if you have suggestions, I'm listening. As always, thank you for watching and have a great week.